Okay, so the problem reads, a child's toy has a 0.100 kilogram ball attached to two strings, A and B. The strings are also attached to a stick, and the ball swings around the stick along a circular path in a horizontal plane. Both strings are 15.0 centimeters long and make an angle of 30 degrees with respect to the horizontal. A. Draw a force body diagram for the ball showing the tension forces and the gravitational force. B. Find the magnitude of the tension in each string when the ball's angular speed is 6.00 pi radians per second. So this is our first force body diagram. It's basically just the same one out of the book. We drew the X and Y axes, and we know that the acceleration is pulling the ball inward. The next force body diagram I drew was a top view showing the acceleration back towards the middle and then the velocities going straight up. And this was the third one that I drew to kind of reiterate with the triangles that the ball makes with the sticks and the angles, and it shows the two tensions. So this one we used to also show our weight, which is mass times gravity. When we multiply that, we get 0.98. We can then take that, we then go to our acceleration, and we know our acceleration equals radius times omega squared. So we do 0.13 times 6 pi squared, and then our acceleration is 46.19 meters per second squared. And then we go and do our our sums of forces in the x and y direction. So we start with the y direction because our y is in equilibrium, so we can set it equal to 0. Force total y equals 0, and then we have t1 sine theta minus t2 sine theta minus 0.98, which is our weight, equal to 0. So we want to get t1 by itself because we want to eventually use t1 as a substitution. And then down here we get our t1 equals t2 plus 1.96, and we can take that into our x equation. So here we have our acceleration, which is our 46.19, set it equal to negative t1 cosine theta minus t2 cosine 30 minus t2 cosine 30, set over our mass, which is 0.1. We multiply our mass on both sides to get rid of it. That leaves us with negative 4.619 equal to negative t1 cosine theta minus t2 cosine theta. Then we multiply through by the negative, so we have the same problem but positive. And here we subbed in our t1 with our t2 plus 1.96 that we got when we solved for y in our y equation. So now we're trying to solve for t2 because t2 is our only variable. So we get rid of cosine 30. When we get down here, we have 5.33 equals t2 plus 1.96 plus t2. Then we have 3.37 equal to 2t2. Divide by 2, and we get t2 equals 1.685. And then now we can take our original equation that we got from our force problem, or y, sum of y, and then we have 1.685 plus 1.96, and then our t1 is 3.645.